Welcome to the build video for the Cystic Fibrosis Awareness Snot Rocket.
CF is when my body makes sticky mucus, and it's disgusting. It's like having super sticky boogers inside, making it hard to breathe and digest food. And I have to do special things every day, like take medicine and do treatments to stay healthy.
Starting with an overview of the simulation, we want to make sure that the sustainer that we're going to use has a high stability margin, because when we add the boosters to it, that's going to move our center of pressure forward and our center of gravity back. With our as-built adjustments and the worst case placement of the parachute, we're just over 2, so that's going to be a good starting point for us. Next, we're going to check the plots. Mainly what I'm concerned here is the ground impact speed. It was windy for the first launch, so we did want that to be a little quicker, but we're looking good so far. With that working out, we're going to move on to looking at the sustainer and booster combo. We can see here the stability margin is a lot lower. We did have that center of gravity moved back and the center of pressure moved forward. One thing we're going to look at here is we didn't simulate the actual chain of events with those boosters separating. So really what we want to see when we go to look at the plots here is even if the boosters remained attached, if they failed to detach, we want to make sure that there was still a safe ground speed. What we don't see here is I did do another simulation where I added a mass element instead of the motors to approximate the motors as if they failed to ignite, and we took off only on the sustainer. And that was an acceptable landing speed as well. So what we ended up doing was just giving a long delay to those booster motors just so they would be out of the way and we could go ahead and see what our terminal velocity would be. One thing to note there, if we did launch the boosters and sustainer on only the sustainer motor, we would have been below a 5-to-1 thrust to weight ratio, but we were well above 3. And with 2 or 3 motors igniting, we are well above 5-to-1. Since we wanted a stylistic edge on the fin here, we did do the freeform. We drew it in Procreate and then brought it over here into Inkscape to add the geometries to make the actual fin can with the centering rings. We didn't do any parametric modeling of this because it was all relatively straightforward. To get that imported into OpenRocket, you have to save it as a PNG with the root edge on the bottom and the fin in black on a white background. Now with our trailing edge looking like dripping goo, we're ready to send this off to the laser cutter.
Laser, 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 lasers!
With those cut out, we're going to mark our tube here to make sure our fins are aligned. We're going to go ahead and start making the motor mount and fin can. So we'll glue in a centering ring to transfer all the force from the motor to the airframe. We'll put a retention clip in, a couple layers of masking tape to hold that down, but still have some spring. Now what we want to do is we want to put the shock cord around the body. So I'm going to mark on the fins where we want to put a notch to allow that shock cord to go around without crimping the tube. And we did want to place this down where the motor will be, just because that'll provide a lot of structural reinforcement as well. Now we're going to add a notch to the bottom centering ring just so that there can be a little travel on that motor clip. Clean that up and then put that on. Once we're happy with that, we're going to make sure that, of course, they line up, and then we're going to get the fins. We're going to go ahead and use CA glue to tack the fins in place. And then we'll come back and do everybody's favorite part of a build video, glue fillet montage. All right, now we're going to come back and we're going to measure and cut the main body tube so that we can mount the fin can. One thing you'll see here is I do just slit the airframe. That didn't end up working out, so you'll see later off camera I came back with a file and expanded those out and then cut little notches in the bottom to help with assembly. Next, we're going to drill a hole out for the rail button mount and then come in with some CA glue and glue that into place. Then we're going to measure off a few body lengths of shock cord and pass that through the body tube so that we can mount the fin can. That, of course, is going to involve more fillets of glue. So we're going to start on the top and do the transverse fillets on the inside of the airframe. Then we'll flip it over, do the bottom side of the top centering ring. Then we'll continue with the bottom centering ring. We'll clamp each of those in place and let them dry before moving on. And once they have dried, we're going to go ahead and move on to the external fillets with the fins and glue those to the airframe. Then we're going to move on to mount the hardware for the strap-on boosters. We'll start by gluing on the bottom mount there, and then we'll use the booster pod itself as a jig. We'll put some glue on the top of that hook, and we'll put it into the nose cone and lever it down. We do have lines marked to make sure that these are nice and parallel with the rocket body. And again, what happens here is the nose cone will come off, and that releases the hook on the top, and then given the drag on the open end of the booster, it'll then fall away nicely, pivoting around that bottom mount. Now all we have to do is mount the top rail button, and we're ready for finish and paint. One thing we did here is we did add 3D texture with just simple hot glue, and then some highlighting with the marker. And with that done, we're just going to tie a simple series of knots to mount the parachute, and we should be good to prep for launch. But before we do that, we wanted to provide a little more detail on how these boosters operate. So you'll see there's a hole in the nose cone that mates through the body tube onto that hook. So when the ejection charge from the booster fires, the nose cone pops off, allowing it to lever that way and separate from the body. So you do use the standard booster motors with a 0 delay on that, and that's sufficient so far to get the separation of the nose cone. Here you can see the parallel wiring for the parallel staged boosters. We'll show that in an upcoming video. And as a quick public safety announcement, that brightly colored yellow rocket is perfectly camouflaged in drying grass.
Yeah, it's like rock and roll.